So this is, in computing terms, this is what's called the Bill Gates effect. Bill Gates gets up to present, and then Microsoft Office then decides to reboot, or Microsoft. So I'm professor of computing at UCL, and most of our work is on actually data infrastructures for the service sectors. And therefore we're in the digital part. What's so interesting about construction is it's actually a next generation integration. You're taking digital infrastructures and you're combining it with what's normally called Industry 4.0. So you have digital objects, paper, designs, etc., right through to physical objects that you might be making in a factory, and this is the way that all the different sectors are going. So in construction terms, you have everything from finance right through to design, project management, finding partners, construction, building management, right through to refurbishment and decommissioning. So this is absolutely the future. What I'm really going to talk about is the different digital technologies, and Abel's introduction was actually very useful for putting things into perspective. So next slide, please. So what we've got at the present time is, if you go back 1 year, we were in a data revolution. All of the different industry sectors, and particularly finance, where I do a lot of work, talk about this later, we're on a sort of 5-year journey. And now what has happened with COVID is that you've got a data tsunami, and companies, you can see this with retailers and manufacturers, are just scrabbling to actually automate and integrate all their particular facilities. Next, please. So what we're seeing is, and all the different, for example, service sectors like finance, are all going through the same sort of transformation. Firstly, companies are actually setting up digital infrastructures so they can integrate all their particular, they're proprietary, they integrate all their services. Next, you move to sort of digital marketplaces where companies, different companies, universities, etc., can actually interact. And now the latest trend is common data structures, sort of, in your terms, sort of open construction, where everybody uses a common data structure, a markup language, data interchange format, so that they can actually collaborate. There's huge amounts of real estate, construction, and regulatory data. The regulators are starting to automate, particularly in financial services, where we do a great deal. What you're doing is you're creating a sort of totally integrated lifestyle infrastructure. Next, please. So what are the opportunities? Well, the sort of journey you're on is for everybody from finance, legal, regulatory, construction, facilities management, all using what I've called a sort of open real estate data structure. An integration of sectors like government, real estate, construction, regulation. So the sort of thing you'll be able to do in the future is to actually check to see whether the buildings you're sticking up are actually compliant. And if the government changes the regulations, you will be automatically informed. So it's sort of real-time regulation and management. This is what I've said, excuse me, about data-driven construction compliance. The other thing we're moving towards is computer executable contracts, regulation, and dispute resolution. We've also got projects which will be fully integrated, where we're actually taking data from buildings, from IoT devices, sticking them in common data structures and analyzing. Energy is a good example of the sort of optimization we're using. Next, please. So what I'm trying to show on this this slide is all the different technologies are actually coming together to create what I call a data net. This is an information management structure that's being built on top of the internet. And most of these technologies you tend to think of as actually being independent, but actually they're a complete technology stack. So at the bottom, you've got distributed ledger technology like blockchain. You've got all the data that you're collecting, both historic and real time, everything from finance right through to construction, regulation. You have a common data model, so that these different components can integrate. You have a what I've called a digital object identifier, which means that everything is uniquely identified. And what this is, I think, probably the most important technology, because what you'll be able to do is you'll be able to track a particular design or regulation or piece of construction that you've done right through the system. What's going on in this area is we're taking concepts like telephone numbers, barcodes, social security numbers, all of these sorts of things, and trying to unify them so that we can actually link together both digital objects and physical objects. And this is the sort of core of digital marketplaces, document sharing, but it's also the core of Industry 4.0, where you can actually track things going through factories. And if it was food, for example, you could actually see it, from the farm, to the plate. So if there are any problems, you can track it. Next is a very interesting technology, which I recommend, is called federated learning. There's a big wave of interest in privacy, and therefore the idea that you can pull everybody's raw data into the cloud and train machine learning algorithms on it really isn't going to fly in the future. So what federated learning does, it allows you to actually keep your data sources or the raw data private and train machine learning systems actually across different distributed data sets. So this will allow, for example, you to compare sort of energy use in buildings for different companies and trying to optimize your machine learning algorithms across this. So this is the privacy preserving data technology. Next, another core technology, which Abel's already touched upon, is computer executable regulations and contracts. This is important if you want to actually do automation, if you want to interrogate government building regulations, for example, or a particular contract to see if you're what course or if you're compliant. And then what's happened at the moment is you've got these sort of silos where you've got financial services, insurance, legal services, real estate, government, etc. are all developing their own individual data nets. And ultimately, these things will be able to communicate. But at the moment, it's a big thing to swallow, just integrating real estate finance with construction, maybe with real estate legal services. Next, please. So a little bit about my own history. Most of it has actually been automating financial services, and therefore I've been really in the sort of digital space. So 25 years ago, we developed a lot of the early financial fraud detection systems and built the first insider dealing detection system for the London Stock Exchange. For the last 16 to 18 years, we built the first, well, about 18 years ago, we built the first algorithmic trading platform in Europe with Deutsche Bank, and this has just totally changed industry. One of the interesting asides that I often relate, 18 years ago when I went to see stockbrokers and I said, oh, we're going to try and to automate share trading, they laughed and they said, one of them said I was an academic idiot, that people didn't want to buy, would never want to buy shares online, and they want to come and have, you know, a nice lunch with somebody with good industry experience. And I've had this this sort of thing, you know, with lawyers and all sorts of other areas where professionals hope it's never going to happen. But, you know, what's happened with COVID is it's not only going to happen, but everybody's scrambling to make it happen quickly. Currently, we do a lot of work in algorithmic regulation or automating regulation, specifically with the Financial Conduct Authority and the Bank of England PRA. And we're getting more and more into regulation of algorithms, the legal status of algorithms, and law tech, which obviously is Abel mentioned earlier. Next slide, please. One of the things, if I can make a plug for universities, is if you take our department, we've got over 300 PhD students and over 650 master's students with expertise in things like machine learning, considerable expertise, and they're a great innovation resource. So, for example, all of our students do their projects with outside organizations like Goldman Sachs or the Bank of England, Tesco's, etc. And they're a great innovation resource. So I encourage you to actually engage with, you know, with the Bartlett as a way of actually doing innovation to lower the risk. Next, please. Okay, I'm just going to very briefly, I've invented this new word called Corvid, which is, I'll get rid of the R later. Go to the next slide, please. What you've got here is what I often call a sort of perfect storm of technologies. Individually, they're interesting, but when you start to actually put them together in a data stack, which I did earlier, then you can do some incredible things. So I've split them here into, you could, a little bit arbitrary, into three areas: data technologies, big data, IoT, chatbots, excuse me, analytics technology like artificial intelligence and federated learning, excuse me, and infrastructure technologies like digital object identifiers, computer executable rules, and blockchain. And just to say it again, individually, the technologies are very interesting from a research point of view, but in terms of actually the future, it's actually them coming together in an integrated digital platform, marketplace, whatever you want to call it, that's actually going to change the world. Next, please. Big data. Often we talk about the AI revolution. The sort of the elephant in the room, you might call it, is big data. The amount of data that you're collecting and actually having to manage and use as part of your business. And what you're getting with big data is a complete integration of government, regulatory, industry sectors. Next, please. So you've got real-time data. You can imagine what the sort of real-time data that we get in for our finance projects. We're now getting anonymous real-time credit card transactions that we can use for investment, so we can see exactly what's happening across all industry sectors. Total data. The big thing is, you start off collecting data just on, for example, on real estate, and then you get business data, economic data, financial data, social media data, and what we call alternative data. And then once you've got this, you can do all sorts of clever things, like you can do sentiment analysis, you can do behavioral and predictive analytics, etc. And as we've seen from companies like TikTok, some of this network analysis is really unbelievable, but also worrying. Next, please. AI. If you want to go to the next slide, I guess. we often talk about AI, but actually there are three different areas. The first is computational statistics, like Monte Carlo methods. Then there's what we call artificial intelligence, which sort of gets all the publicity. And there's actually three types of artificial intelligence. There are so-called rule-based systems, and these are where you code up knowledge in terms of if-then rules. And these are the systems that have been around for about 20, 30 years and are used to drive sort of call centers when you ring up for a loan or such like. These are scripts where you've embedded the knowledge of an expert. It works very well. And one of the nice things about rule-based systems is that you can make them available to non-experts, as it were, and they can actually explain their reasoning, why they've made a decision, which in terms of mortgages and loans and things like that, or legally you have to do it. There's then various optimization algorithms, which we call evolutionary algorithms. And it's just the last one, the machine learning algorithms, which are self-programming, that have got everyone's attention. The interesting thing about self-learning algorithms is because they self-program, it's very difficult to get them to explain the decision making. And people are getting increasingly worried about these automated algorithms actually becoming, unstable, illegal, etc., as we've seen in the press. And then finally, particularly for things like economic modeling, how for example, the construction industry might evolve over the next 10 years. You've got complex systems and particularly things around like agent-based systems. Okay, next, please. Data-driven regulation. This is very interesting. We've done pioneering work with the FCA and others on financial regulation, and there's a lot of push by government to actually do things like have computer readable, computer executable regulatory handbooks. And this means that you'll be able to actually find out whether you're compliant with building regulations in real time. And if things change, and you maybe would need to go in and refurbish a building, the system ultimately will be able to actually give you this information in real time. And the sort of things we look at in financial regulation is to see whether you're compliant in a particular financial jurisdiction. Okay, next, please. This isn't, it's a bit overwhelming, but if you just look at the top, we've done work in automating advice, so you can find out whether you need to be regulated, automated monitoring, which is really just making sure that firms aren't doing anything illegal. Algorithms are becoming more and more important in this space, automated compliance. And the last one, which is particularly interesting from a research point of view, is regulatory policy. So you can actually build models of potential regulations that you might bring in before you actually deploy them. But I would say you should never try and completely automate everything with AI. You should always actually use it as a sort of a tool to do the heavy lifting for humans, and therefore things like enforcement, you definitely don't want to go there. It certainly needs to be handled by humans. Okay, next, please. Federated learning. There are two things going on here. Firstly, it's a way to actually preserve privacy, and this is a major concern for governments, business, and society. So to protect raw data, but it also allows you to train your algorithms across distributed disjoint data sets. And this is important for collaboration. And so I think it's going to have a huge impact. For example, it would allow Tesco's, and Bupa, maybe Unilever to collaborate without them giving up their actual raw data. So I'm sure you can see lots of uses for this in the real estate area. Next, please. Just a little slide on where it came from. pioneered by Google, and it's used to actually build machine learning algorithms to identify predictive keystrokes on smartphones. And if you jump down to the last bullet point here, there's basically it gives you two things. It allows you to do on-device machine learning, where you've got millions of very primitive little devices like cell phones or IoT devices. But at the other extreme, it allows a few big organizations to actually collaborate and actually work together without giving up their data. Next, please. I'm coming to the end now. Now, this is an expansion, mainly for the real estate area, of what's happening with, in my space, digital object identifiers, to move to actually universal object identifiers where you can track everything. So if you think of it in terms of manufacturing, you might start off with, on the digital end, where you've got the internet, blockchain, digital objects, a data model, identifiers, etc., where you're designing a new product and raising finance for that. You then can track the product, a particular product, through the supply chain or the manufacturing supply chain, where you could even identify which machine is available to process it. This is the Industry 4.0. When it was manufactured, you could actually trace it to the retailer that sold it, possibly even to the person that purchased it. So, for example, and logically, you know, if it was a washing machine or something like that, you could actually work out when it was actually recycled. The benefit of this is you've tracked things like food, manufacturing products through the whole life cycle, from finance to scrapping or usage. And if there's any problems, you can actually trace it back through the whole supply chain. And as I say, almost all of my work is in the digital space. But if you have a physical object, you can actually trace it through the whole supply chain. So we're a few years probably away from this, but it obviously has potential for, you know, for real estate and manufacturing. Okay, next, please. Lovely. So if you can stop sharing now. So just to summarize, we're moving towards a completely integrated manufacturing and supply chain, everything through design right through to refurbishment, integrating government and legal services. And the benefit of this sort of vision is that I think it actually puts into perspective what we're doing in particular areas. And it sort of puts a wrap around what Abel was saying at the beginning, where he was trying to move up from blockchain through legal tech, regulation, etc. So I'll hand back now control to Abel, if you'd like to. Anybody like to raise any questions, I'd be pleased to answer them.